Topic is about finding the distance from a point to a line. Okay, so basically, for us to be able to understand the method, let us try to do this example number 20. Find the distance of the point 331 from the line L whose equation is R. Okay, so basically, just for you to visualize it, you have here a line, and this line, this point here, this point, let's say this is point A, is negative 4, 3, 0. That is the point. Now, then there is a point P, and this point P, according to this one, is 3, 3, 1. The distance of the point from the line is basically, you are looking for this, wherein this one is perpendicular to the line. Okay, now what do we know about the line? We know the direction of the line. So this is the direction of the line, and let's say that this direction of the line, according to the problem, is 1 to negative 4. Now remember this R. This R is the position vector of any point on the line. I will write it down. The R is the position vector of any point on the line. So assuming that there is a Q on this line, and this line, this Q is a point that keeps on moving. So it keeps on moving along this line. Now, the specific point of Q that we want is the Q that makes perpendicular with the line to the P. Okay, again, the Q, the blue Q, is moving along the straight line. Okay, but since we are looking for the shortest distance between P and the line, we need to find out what is this point Q. Okay, what is that point Q that makes 90 degrees angle with the P, with QP. Okay, so because if we know the point Q, then we would be able to know the length of PQ, isn't it? Because that's the question. The question is, how long is the QP? For you to be able to find the QP, we need to find that point Q, okay, which is the foot of the perpendicular PQ. Okay, now hopefully that one is clear. But what is that point Q? Remember that point Q is on this line. Okay, let me just replace this. That point Q is this vector, actually this XYZ. So therefore, the point Q is actually the coordinate negative 4 plus 1t. Okay, or I will just write it in the form of vector. So the point Q, or let's say that the point Q has the position vector of, okay, so you're not confused. I will write point Q. The point Q is negative 4 plus t, comma, 3 plus 2t, and then negative 4t. So that is the point Q. Then you have the point P, and your point P is 3, 3, 1. So what are you looking for is the T, correct? We want to look for the T. But how shall we find the T? So that is the question, huh? How to find the T? So for you to be able to find the t, our plan will be like this. Our plan is to find the t, finding the t. We want to find the t. So to find the t, our plan is to take the PQ or the QP, take the dot with the direction of the line. Okay? Direction of the line. Because they are perpendicular with each other. Okay? So therefore, this is 0. Again, why are they perpendicular with each other? Remember that this vector here, the direction of this one is perpendicular to this, isn't it? Because this one is parallel, so this is that direction, and it's perpendicular to your QP. Okay, so basically that is the plan. You're gonna get the PQ, you take the dot product with the direction of the line, and then make it equal to 0, then you will get the value of the t. Okay, now let's find the PQ. The PQ is equal to OQ minus OP. Alright, it's up to you if you want to find PQ, you want to find QP. Remember, they are commutative with each other. So therefore, the OQ is equal now to negative 4 plus t, 3 plus 2t, negative 4t, minus 3, 3, 1. Take note, this is only your PQ. So negative 4 plus t minus 3 is negative 4 minus 3t. Oh, sorry. I overlooked. It's not multiplication, it's addition. So negative 4 minus 3 is negative 7 plus t. Okay. 3 minus 3 is 0, so 2t. So that is 2t. Negative 4t minus 1. Right, so that is now the vector. Now, so we want to take the dot, as the plan, we want to take the dot product of that PQ and the direction of the line. So therefore, PQ dot the direction of your line is 1, 2, negative 4. So 1, 2, negative 4. So therefore, negative 7 plus t, 2t, negative 4t minus 1, dot with 1, 2, negative 4 is equal to 0. So, what did we say? You multiply the 2. So, negative 7 plus t times 1 plus 2t times 2. I think I will just multiply this so I'm not confused. 2t times 2 is 4t. Negative 4t minus 4 is plus 16t plus 4. And that's equal to 0. So this is negative 7. Handwriting is so bad. So negative 7 plus 4 is negative 3. T plus 40 plus 16t is 21t. Okay, plus 21t. So therefore equals 0. 21t is equal to 3. T is equal to 3 over 21 or equal to 1 over 7. So now you have the t. What's the meaning of the t? It means if t is equal to 1 over 7, this point Q, the blue one that is moving, is in this specific location. That's the meaning of that. The t in this point is 1 over 7. Now, You know now the point Q. So therefore, you know the QP. So therefore, to find the Q, to find how long is this one, we need to find the vector QP and then take the magnitude of that vector. Oh, let's do it. So let's plug in. We know the PQ, right? This is our PQ. So we need to plug in this one into this. So let's plug it in here. So meaning to say the PQ is equal to negative 7 plus 1 over 7 to 2 times 1 over 7, negative 4 times 1 over 7 minus 1. So we need to simplify that, and I have no calculator. That is this one. Okay, so that is this. So negative 7 plus 1 over 7 is this. 2 times 1 over 7 is that one. Negative 4 times 1 over 7 minus 1, correct, is negative 11 over 7. Then you will get this answer here. Okay, now what is now the length of the PQ? So the length of the PQ is 1 over 7, the square root of these. Negative 48 squared plus 2 squared minus 11 squared, okay, which is equal to this one. Alright, and if you're looking for the position vector of this point Q, then just simply plug in the t is equal to 1 over 7. Okay, so let's try to write the steps. So what are the steps to find the what I call this one? Shortest distance. Shortest distance between a point and the line. Okay, number 1 is, what did we do here? Express, or I would say let Q as the point on the foot of the perpendicular to the line from P, okay, don't forget, from P. After you let Q, then you need to express Q with the parameter T, okay, using, I would say, refer to equation of the given line. Then after that, after you express the Q with the parameter T, after that is to find PQ in terms of T. After you find the PQ in terms of T, then now you need to find solve for T. How will you solve for the T? To solve for the T, what did we do is to get the PQ dot the direction of the line, okay, is equal to 0. Then once the T is solved, plug in the t in PQ, vector PQ. After plugging in, take the magnitude of PQ. And then after that, the end. Okay? So these are the steps that you need to do to find the shortest distance between a given point and a line.